Hello everyone. So today we are going to solve the problem sum root to leaf numbers. You are given the root of a binary tree containing digits from 0 to 9 only. Each root to leaf path in the tree represents a number. For example, the root to leaf path 1 2 3 represents the number 1 2 3. Return the total sum of all the root to leaf numbers. Okay, test cases are generated so that the answer will fit in 32-bit integer. A leaf node is a node with no children. Okay, fine. So, so what are we given? We have been given this binary tree. Okay, we have to create the sum to leaf numbers and add all those numbers and return the total sum. Like what? Say this is one root to leaf path, right? So what is the number formed? 495. Okay, that's one. Now this is one root to leaf path. What is the number formed? 491, right? And this is another 40. So whatever is the sum is our answer. Okay, that's 1026. Now, in order to compute our number, since we have to traverse the tree from our root to leaf, so we need some traversal techniques, right? So, in order to solve this problem, we are going to solve it using BFS as well as DFS, okay? Iterative and recursive, okay? So, make sure you stay till the end. So, first let's talk about our BFS approach, okay? What are we going to do? We are going to start from the root node, obviously. Now, when we reach at a particular node, what we are going to do? We are going to update this node's value to something like this. It's 4 and 9. The number will be 49, isn't it? We will update this value to this. Okay, so when we come here, this number will become 40. We are creating the number. Okay, now when we come here, this number will become 495. We are going to update the node values like this. Then when we come here, it will be something like 491. Similarly, here it would be 403, and here it would be 402. Okay, so at each particular node, we are storing the numbers, that number which is being formed from root to that particular node. So since till this node, the number 40 is being formed. So here we will store 40, kind of a uh, prefix type of a thing. Okay. Now, whenever we reach the leaf node, okay, what we are going to do? We are going to add this number to our total sum. Okay, 495. Okay, how do we know it's a leaf node? When we don't have a left as well as a right child, right? In such a case, we will add this final number to the total sum because we have reached the leaf, right? We have formed our number from our root to leaf, isn't it? This is the path number, right? Similarly, we will add this one, we will add this one. Okay, pretty simple. So let us quickly write the code for our BFS approach. Okay, so as usual, we will have a queue, and we will add our root node to the queue, and we need a total sum variable equals to 0. Okay, now let's start our BFS. While queue is not empty, just the usual way, while size greater than 0, pull it out, tree node current equals to q dot poll. Okay, now if the left child is not empty, if the left child is not null, okay, we will do something. And if the right child is not null, we will do something. And if it is a leaf node, current dot left equals to null, and current dot right equals to null. If both the children are null, if they don't, both of them don't exist, that means it's a leaf node, right? So we'll do something. Now what to do? If the left child is not null, then definitely we have to add it to our queue, right? Queue dot offer current dot left, and also add the right child current dot right. But what were we doing? We were updating the node value to the number which can be formed from root to that node, isn't it? So current dot left dot val equals to current dot val into 10 plus current dot left dot val. Now what did we do here? We are updating this number to let's say this is the left, okay, this becomes, let's say this is our current, okay, current into 10 plus our left, right? So this, in place of 9, what are we going to put? We are going to put 4 into 10 plus 9, right? That is 49, right? So when we reach here, we will put something like 5 equals to, in place of 5, put what? 49 into 10 plus 5, right? So that's what we are doing here. Current dot left dot value, in place of this, put the previous number, or say the number which we are standing on, into 10 plus our left value, right? So similarly here, this, now we can shorten it like this, plus equals to this, okay. Now if it's a leaf node, then what are we supposed to do? We have formed the number, right, from our root to leaf, so we will add that number to our total sum, plus equals to, plus equals to current dot val, because this 495 will be stored here, right? So we will add this to our total sum, okay. At the end, return total sum. Let's run it, submit, cool. So what will be the time complexity? Very simple, as usual, big O of n, and our space complexity is also going to be big O of n, okay. So this is the BFS solution. So now let's talk about our DFS approach, okay. So for DFS, I'm going to show you two solutions, okay. One by modifying the node values, and one without modifying the node values. So let's see how we can do it by modifying the node values. So the approach is going to be very similar to BFS, right? So we start from our root, okay. Now before going to our left, we first update it to 49, okay. Then we call our DFS at the left. Now our DFS at the left will update this and this, okay. And our DFS call here would update this one and this one, 40. Then we will also call our DFS here, then it will update it, update the values here as well, 403 and 402, okay. And as soon as our DFS reaches a leaf node, okay, it will see if the left and right are null or not. If yes, they will add this updated value to the total sum, okay. Similarly here, 495, our DFS will see that, okay, left and right child doesn't exist, that means we are at a leaf node, so we will add this value to total sum, okay. So what are we going to do? We are going to call our DFS, okay. Now it will first see if we are at leaf node or not, okay. We are not. Then if we are not at leaf node, then that means left and right child exists, right? At least one of them exists. So accordingly, the DFS will update the child values first, okay. Then it will jump to that child, okay. Say we are here, it will see, okay, child exists, okay, we will update this value first, 495, okay. Then our DFS will jump here, okay. Now let's update the values down below if they exist. So it's pretty easy. Let me show you the code. So this is the solution. Globally, we keep a total sum variable, okay, and we call our DFS at the root node. So after it updates the total sum fully, we will return total sum. Now let's see what the DFS is doing. So as discussed already, if our root is a leaf node, then it will add the value, node value, whatever it is, to our total sum, okay, because uh, at each step we are updating the node value, right, and it will return. So this is our base case. Now if it's not a leaf node, then it will have a child. So if it has a left child, we will update the left child value just the way we did in BFS, okay. Say if it's 9 and the previous number was 4 above, so in place of 9 we will put 4 into 10 plus 9, right. Root dot left dot value equals to root value into 10 plus root dot left dot value, right. So this is the thing, and we will call the DFS on our left child, okay. Now our DFS will jump to our left child, okay, and it will modify the node values down below, okay. Similarly for right child, if it's not null, update its value and call the DFS on the right child, okay. It will update the values down below. So again, finally, if when it reaches the node leaf node, okay, it will see that, okay, it's a leaf node, left and right are null, so it will add the modified root value, node value, to the total sum, okay. Then it will return it. So this is the solution. Now its time complexity is big O of n, clearly, right, and space complexity is also big O of n if you consider the recursive stack space, okay. Now How to do it without modifying the node value? Let's see. It's very easy. We just have to keep the track of the number which we are forming, okay, on a separate variable. Okay, so let's call our DFS from here. Okay, our number is 0 initially, right? So when we come here, our number becomes 4, isn't it? Now we call our DFS on the left child and the right child, isn't it? So after calling it, what we will do, we will update this number to something like 49. Okay, that is 4 into 10 plus the current node value. Okay, this is on a separate variable. Okay, we are not updating the we are not modifying the node value. Similarly here, the number will be updated to this. Now we will call our DFS again on the left and right child here. Okay, so what will be the number found? 495, right? And as soon as we see that it's a leaf node, that means left and right child are null, we will add this number to the total sum. Okay, similarly we will call our DFS here and the number formed will be 491. Now as soon as we see it's a leaf node, we will add this number to our total sum. Similarly, we call our DFS at this one. Okay, we form the number 403. Now when we see that the leaf node is a leaf node, we will add this. Our DFS will be called on this child as well. Okay, so when we see 402, when we see that it's a leaf node, we will add this too. Okay, very simple. Let's see the code. So this is the code. Okay, as usual we keep a global variable total sum and we call our DFS on the root, and initially our current number is 0, right? Our current number is 0. Then we will return our total sum. Okay, now let's see the DFS method. If our root is null, then return. Pretty easy. Now otherwise, if our node is not null, it will have a value. So update our current num. How? Say our current num is 4 for now. Okay, then after reaching the child, let's say the child value is 9. Okay, so our current num will become current num into 10 plus our child's value. Okay, that is 49. Now this is our current number. Got it? Okay, now we will see that if this current node is a leaf node or not. If it's a leaf node, then to our total sum add the current number that we have formed so far and we will return from here. Otherwise we will call our DFS on the left and we will call the DFS on the right. Okay, so for this we have kept the this check here if root is not null, because otherwise instead of putting this we can also do something like if root dot if left is not null then call this, and if right is not null then call this. So in that case this check wouldn't be required. Okay, so it's pretty easy whichever way you do. Okay, so this is the solution. Let me revise it once more. If our root is null, return. Otherwise update the current number. Okay, current number. Then if it's a leaf node, okay, if it's a leaf node, then add the current number which have been formed so far. Okay, that is from the root to the leaf. Okay, add it to total sum. Okay, and from there return. Otherwise call the DFS on the left child and call the DFS on the right child. Okay, so this is the solution. The time complexity is again a big O of n, and the space complexity is also a big O of n, considering the recursive stack space. Okay, so yeah, that's all from my side. If you have any doubt, you can put it up in the comment section. Other than that, if you like this video, do hit the like button, share this video and subscribe to my channel, and I will see you in the next video. Bye bye.